Welcome and hello. This is a video tutorial on HEC DSSVue, and in this lesson, I'm going to be discussing scripting. This is the second part of a lesson on scripting, so we're just going to do another example here to reinforce this whole concept. Okay, what I have on the screen here is my DSS view. I have my .dss file open here with a number of data sets for daily precipitation, and each of these data sets represents 1 year. So if I open up a file, this is 1886, and a little bit later in history, 1939. This is what we're looking at here. What I want to do in this particular scripting exercise is to take all the data from all these years and find the average daily precip for that day by adding up each individual precip value, and then for each individual day, and then subtracting by the number of years that I have here in record set. Okay, so once I get started, hopefully it'll make more sense, but we're going to go up to Tools and then Script Editor. And here is our script editor. Typically, we'd go File, New, and then start a script this way. But what I'm going to do is actually write my script outside of HEC DSSVue, save it as a .py file, and then go File, Import, and then search for that file, bring it up, and then run it on the data. So it's a little bit different method than this right here. Okay, I'm going to start by going to this website here. It's the GitHub website with a number of good examples. So this one is called add10tsc.py. The previous lesson, we used the add10hec math.py. I'm just going to start by copying this code to my clipboard as a starting point, and then heading over to my Notepad++ and pasting that in. I'm going to just actually first save the file so I don't forget. And I'm going to call it average daily precip.py, save it to my desktop for easy access. Okay, so here is that file. I'm going to start deleting some of this extra comments that I don't need, and then add some of my own comments. First thing I'm going to do is add a comment at the top to say I'm averaging the precip in Sacramento over 131 years of data. The next thing I kind of learned the hard way was I needed to include another module here called the time series container. We'll get to that a little bit later. And then what I want to do is kind of structure the code into parts so I know what I'm doing, and then I can do it. So I'm kind of building an outline first. The first part is going to be getting the precip data sets. So each data, I'm going to have 131 records saved to a list in Python. The next step is to actually calculate that average daily precip. So first I'm going to total it and then divide by the total number of years. And then the last step I'm just going to paste in the comment is to save the data set to the .dss file. And that's where this time series container is required. Okay, let's go ahead and get started. Okay, the first thing I need to do is get the DSS file with all those records. So I'm going to go down to the code that I copied in and steal a line from that. Here's the DSS file. The first argument is the file path, and then the second is the date time range. I don't need a range, so I'm going to delete that second parameter. And then for this file path, I'm just going to go back over to HEC DSSVue, and it is video 13, and then right click copy, and then back to my code and paste. All right, one thing it likes to do is see slashes, not backslashes. So if you run it with the slashes, it's going to say it can't find the .dss file. All right, that looks good. Next, I need to define the date range. So I'm going to say year first is 1878. Year last is 2008. Years total is the difference plus 1, year last minus year first. Okay. Next, we want to create a empty list, which will serve to contain all the data sets. Next, we want to loop through those years. Next, we want to define the dataset path name, which will be, let me head over to HEC DSSVue. That is the path name for each of these data sets. And thankfully, they only vary by the year. So let's take the first year, 1878, and then click rename, and then we can just highlight the path name here at the top and close that, and then head back over to my code and then paste that in there. So we have the year is the only thing that changes. So I need to change that to year. And so this variable year here is referencing this year in the code. Okay, that looks good. And lastly, we just need to push that data set, precip data sets, and then we can paste this reference in there. Okay, so that's it for the first part. We've got all of our data sets collected in this precip data sets list in Python. And this is just some very simple syntax in Python. If you haven't used Python or Jython before, then there's you can probably get up to speed on this pretty quick. All right, next up is the daily precip average. What I want to do in this block of code is loop through each year, and then within the year, I want to loop through each day and append that daily rainfall to the same day in previous years. And then the very last step will be to divide by the total number of years to get the average. So we're going to start with the total first. Okay, I'm going to be pasting in some of this code to save time, but I've just initialized my daily precip total list here with values of 0. And then after that, I can actually just loop through the same information here, copy, paste. This is perhaps not the most succinct way to write this code, but I do like how I've organized it. I'm looping through the years. I'm selecting the data set, which is based on the year. Okay, I'm pasting in these 2 lines here to skip leap year. Sorry. February 29th is just going to get excluded from this analysis for just keeping things simple. Next, I'm going to be adding those values up and then incrementing my iterator I by 1. And this last line here is the last line of the section, which is to basically divide the total precip for each of the values by 131. So this 131 is actually should be the year's total variable, because that can change, and precip total and the daily precip total. Okay, looks good. The last step here is to actually save that data set to our DSS file. And yeah, we don't need this anymore because I'm just copying text from a previous example I was working on. Okay, I'm going to paste in the next few lines here. TSC is the object name for the time series container object that I'm creating here on line 37. And then there's a number of parameters I need to define. Obviously, the name itself, which is going to be the same thing as we were using up above. I'm going to actually use the first year. And instead of OBS for part F, I'm going to be using average. And then the next line down is where I actually put in the values. So I'm assigning the values to that. Okay, and then the last part of the code is just more metadata. Basically, we got the start time, end time, the number of values, and then the units is inches, and then the type is going to be period average. And then the last 2 lines is actually writing the file, so that could be a separate section, but I'm writing the data set to the .dss file and then closing the DSS file handler. And I do want to keep these last few lines for error handling because it's likely I mistype something, and the message box will make it easy to debug and hopefully find the error. Okay, so I'm going to go ahead and hit save, Control S, and this is just a save in a text editor. I'm using Notepad++. I'm going to go back to HEC DSSVue. All right, so let's go up to Tools and then Script Editor. And let's see, File, Import. I'm going to go to my desktop and hit Open. Now here is the script that we were just working on and we saved. Here's the name, average daily precip. I'm going to bring it into all 3 places for viewing and running. So I'm just going to hit save right now. Okay. Here is the button to run the code. So drum roll, please. And I clicked it and it seemed to work. Silence is success, right? Let's see. I don't see any errors here. Let me see if refreshing will make it show up. And sure enough, it did. We got 2 records for some reason. Let's take a peek at this plot here. Okay, no data. That's not a good sign. And let's take a look at this plot here. Also no data. What happened? All right, I think I found the error, guys. Typo right here. This variable should be daily pre-sip. I had an extra I this year. So that is the correct value. And let me hit save and then go file. Sorry, tools. Back to the script editor. Okay. Let's actually delete that one. Now, actually, I could make the change in here, but then it wouldn't save to the file I have saved locally on my machine. So when I'm doing this file import operation in the DSSVue script editor, it's just making a copy by value. It's not keeping a reference or updating the code in any way. So keep that in mind if you happen to be writing your scripts outside and then importing them like I'm doing here. Okay, let's give that a save. And then okay. And let me delete these two before I run it. We right click, delete. Okay. And let's run it. And then I'm going to go view, refresh, and let's see if we have any data now. Okay, great. So we have data, and that's pretty much what I was expecting to see. Obviously, there's a lot of noise that could use some smoothing. And then let's see what this record is. Okay. Not sure what's going on there. I'm not going to spend any time in this video figuring that out, but it is, yeah, it's just one data point. So I'll get that figured out. But anyway, this is what I was going for. This curve here, it looks like, let's go ahead and just do a quick smoothing operation on, I have it selected. I'm going to go Tools, Math Functions, Smoothing tab. And then I actually want a fairly large number here. It needs to be odd, greater than 2. Let's go with 21 and just see what that looks like. Compute. And then let's take a peek. Oh, yes, much smoother. I mean, not perfect, but much better than it was. So let me save that. I'm going to say part F is going to be, I'll say dash smooth 21. Okay, it's saved. And now we could actually plot them together and see what that looks like. Just don't need that middle one. Yes, that looks pretty good. Let me go ahead and just modify that curve a little bit. I'm going to zoom in so it's easier to select. Edit properties. Yeah, let's make this smooth line red and maybe a little bit thicker. Apply. Very nice. So here is our plot. That red line shows the average daily precipitation here in Sacramento over that 131 years of data. So this was just another example of how to use scripting in your HEC DSSVue. Maybe not the best way to do it, but an exercise to learn the basics nonetheless.